Now in this worksheet, I'm going to talk about Child's law. All right. Now, first Child's law, the formula is V1 over T1 equals V2 over T2. Right, so the V here is the volume in terms of milliliter or liter, and the T is temperature, must be in Kelvin. So if I give you degree Celsius, before you plug it into the formula, you have to change the temperature by adding 273 to get Kelvin before you plug it in formula. And then your answer from the formula will be also in Kelvin. So if your question asks you, hey, what's the answer in the temperature in terms of degrees Celsius, you have to take your Kelvin temperature, subtract 273 to get degrees Celsius. So you have to be really careful. Whatever you plug it in or whatever you get out, the temperature must be in Kelvin. Okay? And then the pressure is the constant. Now in this case, the example is if I heat up the flask, okay, if I have a flask, let's say if I have a balloon, okay, and on the bottom if I heat it up, and because I increase my temperature, the pressure is going to be increased, so then I'm sorry, if I increase my temperature, I'm going to increase the volume, so then the balloon will blow up. So if I increase my temperature, the volume will be increased to blow up the balloon. So this is the example, you're heating up a flask, will blow up a balloon attached to it. Okay, so here is when I increase my temperature, my volume will be increased, my temperature decrease, my volume will decrease. So this is a direct proportional. And then because of that, the graph will look like a straight line. I increase my temperature in Kelvin, I increase my volume. So this will be like a straight line relationship, directly proportional. Right? Now here is, again, your formula would be V1 over T1 equals V2 over T2. Again, your temperature must be in Kelvin. So if I give you degrees Celsius, before you plug in the temperature into the formula, you have to add 273. And then if I come out with the temperature is the degrees Celsius, if I come up with the temperature from the formula is the Kelvin, how can I find out the temperature in degrees Celsius? Is I have to take the Kelvin, subtract 273. All right? And then again, change in temperature, change in volume will be these two formula. The change in temperature is the difference between the two temperature, and then the volume difference between the two volume. Okay? So here again, I have to, the T2 would be like, for example, in this example, the 4 degrees, I have to add the 4 degrees to 73 to get to 77 before I continue. So you have to change the temperature from degrees to Kelvin before you plug it in formula. Now in this case, my formula will be given fraction. Before you start, you want to cross multiply them. Okay, to become this, and then you want to divide it for whatever you don't want to stick with the unknown that you're looking for. That would be the easiest way to do. And then you plug in the numbers to round it to two places. And then change your volume would be the V1 minus V2. Okay, so same idea as a boil stop. So first of all, on the number 2, the reference answer is wrong. The reference answer should be, let me change the reference answer. Should be about 48.4. Okay, so the reference answer is wrong, so fix that. Now here, what was the initial temperature of the balloon in degrees Celsius? So I'm looking for my T1 equals question mark degrees Celsius. If the volume changed from 40 liter to 2.3 liter, so my 40 liter will be V1 and my V2 will be 2.30, and the final temperature will be 25 degrees. So this is my T2, but it's degrees Celsius. Okay, at the same pressure, meaning T1 P1 equals P2, same pressure. And what's the change in temperature in degrees Celsius? So I'm looking for also my T1 minus T2 equals question mark degrees Celsius. So here is actually two parts of the question. So we first list out what we have. Okay, so my T1 equals question mark degrees Celsius. Okay, and then my V1 is 40.
Jolitha McNary Wright, please report to the Azure Dean's office. Jolitha McNary Wright.
So my volume 1 is 40, and then my volume 2 is 2.30 liter, and then my T2 is 25 degrees Celsius, and then my P1 equals to my P2. Now, because this is Charles' law, your temperature in the formula must be Kelvin. So this is no good. And we need to change the temperature from 25 degrees by adding 273 to get 298 K. Okay? Now next, we're going to use green pen to decide what law is that. Okay, so what are changes? Okay, so my temperature are changed and my volume also get changed. So my T and the V are changed. And then what is constant? My pressure is constant. Right? So based on these two situations, this is a Charles' law. Well, how do I know Charles' law? Because on the table, I already tell you, my volume and my temperature will be changed, right? And then my pressure will be constant. So based on these two, I know Charles' law. Again, you don't want to skip this because later on you're gonna have 7 the laws together. So because of this Charles' law, I'm gonna write this equation. The formula is V1 over T1 equals V2 over T2 using blue pen. So whenever you have the formula with the fraction, the best way to do is cross multiply. So after the cross multiply, I got V1 T2 equals V2 T1, right? And then I'm going to rewrite this again. Okay, I'm going to rewrite this again. I'm looking for my T1. So I have to get rid of my V2. So how can I get rid of my V2? I develop V2 on both sides. I'm looking for my T1, right? So I have to get rid of V2. So how can I get rid of it? It's develop the V2 on both sides. Okay, so after that, I will isolate my T1 by itself. So my T1 will be equals to V1 times T2 over V2. And then I can put the numbers in. My V1 is 40.0 liter, and my T2 after change to Kelvin will be 298 Kelvin. And then over my V2 is 2.30 liter. I cancel my unit, which is liter. And then I will get, from the calculator, I get 5182.608696 from the calculator. Okay, and then after the rounded two places, I will get 5182.61, which is in the unit of Kelvin. However, the question asks me, what is the temperature in degrees Celsius? So if I give you Kelvin, how do you change back to degrees Celsius? Is you subtract 273. Okay, so I subtract 273, and I will get 4909.61 degrees Celsius. So this is my part A answer. Okay. Now part B was the change in temperature. Okay, so my change in temperature is the difference between the two. So black pen, change in temperature is equal to absolute value of T1 minus T2. Now they must be in degrees Celsius. So then you have to take the T1 is 4909.61 degrees Celsius. 4909.61 degrees Celsius minus. Now here you don't want to minus 298 because this is Kelvin. You want this to be degrees Celsius, and that's why I made mistake here. I take the 298 by accident. You should take 25 degrees Celsius because your answer is degrees Celsius. So should be subtract 25. Okay, so this is 9 actually. Okay, so don't make the mistake, don't take the 298 because this is Kelvin. It has to be degrees minus degrees. And after that, I should get 4884.61 degrees Celsius. So this would be my part 2 answer. What's the change in temperature?